We are taking R.D. Sharma solution, class 10 maths, chapter number 13, exercise 13.1. This is probability. What is the probability that a number selected at random from the number, this is the list, will be their average? That is, what is the average? First of all, we need to find out the average. So just add all of them and divide by the count of the number. So how many numbers are there? If you count them, these are 10 numbers. So if you add them, just total them, just add them and divide by the total numbers. That is sum of numbers divided by total number. The total number, the count of the number is 10, and when you add them, it is going to come 30. So 30 by 10, that is 30 by 10 is 3. Average of the numbers are 3, is 3 actually. So now we are selecting the numbers and 3 should come. So what are the favorable cases? How many 3s are there? 3. 3 3s are there. And how many numbers are there? Again, the count is 10. So 3 by 10 is the probability of getting the average, which is actually 3. We got the average first and then we found out the probability. There are 30 cards of same size in a bag on which 1 to 30 are written. So 1 to 30 are written. So there are 30 cards. That means we will have the total number of cases of possible outcomes are 30. One card is taken out of the bag at random. So one can be taken from these 30. Find the probability that the number on the selected card is not divisible by 3. So how to find this? See, not divisible is always challenging. So the best way is to find out the count of the numbers which are divisible by 3, or you can say the probability of divisible by 3. So we can always subtract this probability by 1 so that we get not divisible by 3. Let us just read the table of 3. That is the table of 3. 3 was the 3, 3 to the 6 like this up till 30. And then count. Okay, this has to be between 1 and 30. So these are the numbers only between 1 and 30. Now all these numbers, how many counts are there? You just have to count. So these are 10 numbers. So 10 are the possible outcomes, 10 are the favorable outcomes, and 30 is the possible outcomes, which are the 30 cards. So 30 by 10, that is 1 by 3 is the probability of getting a number divisible by 3. But we need to find not divisible by 3. So we know that getting and not getting, if you add, you get 1. That is probability of having it and not having it. If you add them, it is going to come 1. How to get the not if divisible by 3 is there? So just subtract this by 1. So you get 2 by 3. This is the probability of the selected card which is not be divisible by 3. A bag contains 5 red, 8 white and 7 black balls. A ball is drawn at random from the bag. Find the probability that the drawn ball is red or white. So red is R, that is 5, white is 8. So red is 5, white is 8, 5 plus 8. And what is these are the favorable cases for the first part of this question. Favorable cases are 5 plus 8. And what are the total cases? If you just add them, 8 plus 7 is 15, 15 plus 5 is 20. So 5 plus 8 by 20, that is 13 by 20 will be the red or white. Not black. As I just suggested, that in order to find this not black, let us find out the black. How many blacks are there? 7. So 7, how many possible outcomes are there? It's 20. 7 by 20 is the black. This is the probability of getting a black. How to find out that not black? You just subtract it from 1. 1 minus 7 by 20, which is going to be 13 by 20. Now let us come to white or black. So find out the probability of white and black. What is the white and what is the black? If you add them, it is going to be 15. So white or black probability is given by the total number of white and black divided by the total number of the cards, that is here in case 20. So this is 3 by 2, 2 by 3. But 2 by 3 is the probability of white or black. But we have to find neither nor. So just subtract this by this number. 1 minus 2, 15 by 20, that is 3 by 4. 3 5 is a 15, 4 3 5 is a 5 3 is a 15, 5 4 is a 20. 1 minus 3 by 4 is 1 by 4. So 1 by 4 is the probability of neither white nor black. Find the probability that a number selected from the number 1 to 25. So here we see that the denominator is known for a probability. 1 to 25, that is the total number of possible outcomes, is 25. Is not a prime number when each of the given numbers is equally likely to be selected. So equally likely, we don't want a prime. So let us find out the prime numbers. Find out the probability of having a prime number. And then we will subtract it by 1 to get not a prime. That is, how many primes are there? Just start from 1. 1 is not a prime. 2 is a prime. 2, 3, 5, 7 till 23. So these are the numbers. Prime numbers are those numbers which are divided by themselves or 1. There is no other number which can divide them. So all these are the list of this set is the list of the number which are prime numbers between 1 and 25. So just count them. How many are there? 9 are there. So 9 are the favorable cases and 25 are the total cases. So 9 by 25 is the probability of getting a prime number. But we are being asked about not a prime number. So we have to subtract this by 1. 1 minus 9 by 25, which is 16 by 25, is the probability. A bag contains 8 red, 6 white and 4 black balls. A ball is drawn at a random from the bag. Find the probability that the drawn ball is red or white. So red or white. So red and white, or means this, or means plus. So just add the numbers of 8 red and white, that is 8 plus 6, 14 by what will be the total one? 8 plus 6 plus 4, that is 18. So 14 by 18 is the probability of red or white, which is going to be 7 by 9 if you just simplify it. Not black. Again, let us come to the black one. First find out the black one. How many blacks are there? 4. So 4 is the probability of getting a black, that is the favorable cases are 4. And how about the total number of cases, which are 18? 4 by 18 is, that is 2 by 9. This is 2 is a 9, 2 9 is 18. 2 by 9 is probability of getting a black. But we are being asked about not black. So we have to subtract it by 1. 1 minus 2 by 9, which is going to be 7 by 9, is the probability of not getting a black. Now neither white nor black. So let us see white and black. How many whites are there? Black are there? Nor, that is, here we have, or we also have a or. So we will add them. 6 plus 4, that is white and black. 6 plus 4 is 10. Total is, of course, every time we are using 18. So 10 by 18. If you just simplify it, it will be 2 5 is 18, 2 9 is 18. 2 9 is 18, 2 5 is 18, yeah. 5 by 9 is the probability. But we are interested in what? Neither nor. So we have this is the probability of having white or black, but we are interested in neither and nor. So we just have to subtract it by 1. This will be 9 minus 5 by 9 minus 5 by 9, that is 4 by 9. This is going to be the answer. Find the probability that the number selected at random from the number 1 to 35 is a prime number, multiple of 7, multiple of 3 or 5. So let us start by prime numbers. So the best way is to what? Find out the numbers which are prime. Prime numbers are those which are divided by themselves or 1. No other can divide them. So let us have a list of all those prime number between 1 and 35. And this you count, if you count, it is going to come as 11. But how many numbers are there? 35. So 35 is the total number of outcomes, possible outcomes, and 11 is the total number of favorable outcomes, that is 11. 11 by 35 is a prime number. The multiple of 7, just follow the table of 7 between 1 and 35. So if you just take 7 ones are 7, 7 2 is 14, 7 3 is 21, 7 4 is 28, 7 5 is 35. So here we have a table of 5, but this is between 1 and 35. You count this number. How many numbers are there? It is going to be 5. So total number the favorable to us is 5. And how many numbers? Of course, 35 is the total number of possibilities. So 5 by 35, this is going to be 1 by 7 is the probability of getting multiple of 5. How about multiple of 3 or 5? So let us take table of 3, let us take table of 5 and just write them and take the common one, like 3 1s are 3, 3 2s are 6, 3 5s are 3 3s are 9, 3 4s are 12, 3 5s are 15 and 18, 21, and it goes up to 21, then 24, 27, then 27 and 30 and 33 and 36 will go out, so we stick around here. This is 33. Now let us compute the 5 tables. So 5 ones are 5, 5 is a 10, 15, 20, 25, 30, bus. This is enough, right? So let us take the common number. So we'll write 30 only one time, and that is 30. Let me write it here. 15 also one time. Is there any other number which is common to these tables? No. Now we'll write all the numbers like 3, 6, 9, 12, all these. 15 will write only one time. See here, only we have written one time, and this 30 will also write one time. Otherwise all the numbers will write here. So how many numbers are there? Count this. This is going to be 16. So 16 is the multiple of 3 or 5. We have added these two. That is why we have taken only one of these and combined these in one set. It will be 16 number in all, and of course we have 35 as the total possible outcomes. 16 by 35 is the probability of multiple of 3 or 5. From a pack of 52 playing cards, Jack, Queen, Kings and Aces of red color are removed. So we have 52 cards, 26 red, 26 black. So Jack, Queens and Kings and Aces. So there is S. So multiple number of Jacks, multiple number of Queens have been taken off. So we have in this 26 we have 13 as one suite, 13 as other suite. We know we have the 4 suites are the diamond, club, spade, like this, and hearts. So now this 13, 13, 4 has been taken off. 4 has been taken off. It has been red from red. It has been removed. So only what is remaining here? 13 minus 4 is 9. 13 minus 4 is 9. So we have the card is the total number of cards are 9 plus 9 plus 26. Okay, did you get it? 9 plus 9 plus 26, that is 18. 26 plus 18. How much is this? 4 and 44. 44 cards in all we have. You can do it by this way also. See, 52 cards are there, and Jack, Queens and Kings and Aces. So 2 Jacks from here, 1 Jack from here, 1 Jack from here, 2 Queens, 2 Kings and 2 Aces. So you can just subtract 52, this 2 from 52. So same thing is going to come. 44 is going to come. So the same way, these are the two ways to understand this. Now 44 is the total number of possibility we have. In all the cases, we are going to take the denominator as 44. Now first is a black queen. Black queen. We are not interested here. So black, of course, we will have 2 suites here. One queen will be here, one queen will be here. But in all, we have just 44 cards. So 2 by 44. A red card. See, in red card, we have 13 minus 4, 13 minus 4. That is only 18 cards are there. Right? Only 18 cards are there. So 18 cards are there. And total number of cards are 44. So 88 by 44. You can also see like this. 26 card is there. 4 from here, 4 from here. That is 26 minus 8 cards are the red cards. Because 8 cards have been removed. Because they were Jack, Queen, Kings and Aces. So 26 minus 8, that is 18 is the favorable cases. 44 is the total number of cases. How about a black Jack? Now you have a black because 26 cards are there. And there will be 1 Jack. 1 here, 1 here. So we have 2 Jacks. One from this suite, black suite, and one from this suite. So 2 is the possibility, the favorable cases, and 44 we have the total card. So 2 by 44 is the probability. A picture card. Picture card are the cards where picture is being shown on that card, that is Jack, Queen and Kings. These are the picture cards. So we have, see, 3 cards here, 3 cards here which has been taken off. So we will not have this one. We will have picture cards here, that is 3 from here, 3 from here. These are already been removed, so we don't have face cards from red. We will have only 3 cards from one suite of black and 3 cards from one suite of black, that is Jack, Queen and King here, and Jack, Queen and King here. That is 3 plus 3 is 6. 6 is the favorable cases, 44 is the total number of cases. 6 by 44, that is 3 by 22 is going to be our probability. A bag contains lemon flavored candies only. Malini takes out 1 candy without looking into the bag. What is the probability that she takes out a orange flavored candy? When you only have lemon, that is, an orange is not there. How can you find an orange? So this probability is 0. You will not find orange candy in a bag which is filled of lemon candy. What is the probability of a lemon flavored candy? So all the box has is lemon flavored candy. When you have a lemon flavored candy, you can only get a lemon flavored candy from there always, even if you pick any of the candy, because there is only lemon flavored candies. So the probability is 1. So this is called the sure event, and this is called the impossible event. So this is the discussion solution you have to write in your exam or assignment like this, exactly like this. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that 2 students have the same birthday? So we are already provided the probability of having not. So not plus yes, no plus yes is always 1. That is the probability of you can say the event here is the event of 2 students or people having same birthday in this class is going to be 0.992 event. But the 2 students not having the same birthday, we just write it using E, that is the event with a bar. So when you add them, it is going to be 1. But 1 probability of having is given, so not having will be just subtract this number from 1. That is, you have to take this on this side, which is 0.992, and 0.992 is 0.008. A bag contains 3 red and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red, not red? Red. That is, 3 possibilities are there. 3 favorable cases are there. And what is the total number of cases? 5 plus 3, that is 8. 3 by 8 is the probability of getting a red because 3 is there. So only 3 can come. And total number of balls are 3 plus 5. How about not red? So not red, just subtract this having red with 1. It is going to be 5 by 8. So this is how you have to understand. This is how we go. But the way you write it is the way it is being shown in the solution here. A box contains 5 red marbles, 8 white marbles, and 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be red, not green? So red is 5, so 5 is there. Total is what? 5 plus 8 plus 9, that is 12 plus 5, 17. 5 by 17 is the probability of getting a red, right? Now what is the not green? So let us find out the green. Subtract it by 1. Green is what? 4. Total is 17. Having a green is 4 by 17. Not having a green is 1 minus 4 by 7, which is going to be 13 by 17. A lot consists of 144 ballpoint pen, of which 20 are defective. So we have 20 are defective and others are good. So 20 are defective and good are, just subtract 20 from here. 1, 2, 4. 125 are good. These are defective and these are good ones. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws 1 pen at random and give it to her. What is the probability that she will buy it? She will buy it, that is, it has to be a good one. Okay, so how many goods are there? 124. 124 are good. And how many total are there? 144. So the probability she is going to buy is 124 by 144. She will not buy it, that is, the shopkeeper draws a defective one. And how many defectives are there? 20. 20 is defective. How many full numbers are there? 144 pens are there. 20 by 144 is the probability of that she is not going to buy. And if you just simplify it, 124 by 144 is going to be 31 by 36. And this second one is 5 by 36. If you just simplify this 20 by 144. The other way is she will not buy it. Just subtract this number from 1. You will get the same number here. That is 1 minus 31 by 36. That is, if you subtract this from 1, it is going to give you the second answer. That is she is not going to buy it. 12 defective pens are accidentally mixed with 132 good pens. So 132 are good and 12 are defective. It is not possible to just look at a pen and tell whether or not it is defective. 1 pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. How many goods are there? 132. How many total numbers are there? 132 plus 12, which is going to be 144. 132 by 144 is the probability of getting a good one. So this is how you are going to write. It is going to be 11 by 20, 11 by 12 if you want to Just simplify it. 5 cards, the 10, Jack, Queen, King and Ace of Diamonds. These are well shuffled with their face downwards. One card is then picked at random. That is, we have just 5 cards. So we have 5 as the base or denominator, or you can say total number of outcomes. And these are of a suite which is called diamond. 13 cards are there in diamond. So these 5 cards we are talking about. 1, 2, 3, 4, 5. One card is then picked up. What is the probability that the card is going to be queen? So how many card queen is there in 5? 1. So 1 is queen, 5 is the total number of cards. 1 by 5 is the probability of getting a queen. If queen is drawn and put aside, what is the probability that the second card pick up? So before we go to this question, see, these 5 cards, already one queen has been taken out. So only 4 cards are remaining. So for these, we have a denominator as 4. First of all, you need to understand that one card from these 5 lot, queen has been taken out. Now we have to find the probability of getting an ace. How many aces are there? This has already been taken out. So in this 4 card, 1 is ace, so 1 by 4. How many queens are there? There is no queen. So 0 queen. So the probability is 0 here for a queen. This is how you are going to write this. Harpreet tosses 2 different coins simultaneously, say a 1 rupee coin and a other of rupees 2. What is the probability that he gets at least one head? At least one head. So first of all, you have to make the combination. So head, tail, head, tail, head, head, tail, tail. So these are the 4 possible cases. These are 4 possible cases. You can also say that because 2 outcomes can come, head and tail. How many coins are there? 2. 2 to the power 2 is 4. So this is how you can compute also. So 4 possible outputs are there. So we just say 4 is the denominator. That is all the possibilities here. Now at least one head. Let us find out. Here we have 2 head we can take. Here 1 head we can take. 1 head we can take. So 1 head, 1 head, 1 head. That is this count is 3. So having at least one head is 3. So 3 by 4 is the probability of getting at least one head. Card marked with the number 13 to 60 are placed in a box and mixed thoroughly. That is 13 to 60. So you have to count how many numbers are there. 13 to 60. One card is drawn at random from the box. Find the probability that the number on the card drawn is divisible by 5. So you have to write the table of 5 between 13 and 60. Please understand, you have to write numbers between 13 and 60. Right? With these 2 numbers, of course, inclusive. A number is a perfect square. Now you have to write the perfect square. Like you cannot write 4. 2 square is 4. You cannot write 3 3s are 9 or 4 4s are 16. Yes, 4 4s are 16 you can write. 4 or 9 you can not write, but 16. 4 4s are 16. 5 5s are 25. 6 6 are 36. 7 7s are 49. And 8 8s are, it goes up. It is a 64. So you cannot write this. You can just write this. So the number is a perfect square is 4. This count is 4. 1 2 3 4. How many numbers are there? From 13 to 60. You just subtract 12. So you get from 60 minus 12 is 12. 16 minus 12 is 48. So you have 4 favorable cases and 48 as the total number of cases, which is going to be 1 by 16. Let us come to divisible by 5. So you just write the table from 13 onwards. So it will be 15. You cannot write 5 or 10. You have to start from 15 because the numbers are from 13 to 60. And you have to stop at 60 because you know the table of 5 generally we learn up to 10, but it has to go up to 60. Count the number of elements here. It will be 10. The total number of possible cases are 10, or favorable cases are 10. I'm so sorry. Favorable cases are 10, and total number of possible outcomes are, of course, 48. From 13 to 60, how many numbers are there? It is 48. So 10 by 48 is going to be 5 by 24. A bag contains tickets from 11 to 30. So how many numbers are there? Just subtract 10 from here. So you have in all 20. In all 20. So 20 will always be the denominator in both the cases. So 20 is the total number of possible outcomes. A ticket is drawn out from the bag at random. Find the probability that the number on the drawn ticket is a multiple of 7. So what you have to do here is just write the table of 7 and the numbers which are between 11 and 30. So multiple of 7 is 14, 21, 28, and please understand that these numbers are actually between 11 and 30. So 14, 21, 28, these are 3 count. So 3 is the total number of favorable cases. And how many number of we count between or in 11 and 30? This is going to be our possible outcomes. So 30 by 20 is the number which is probability of multiple of 5. Now, is greater than 15 and a multiple of 5. So it has to be greater than 5 and a multiple of 5. So greater than of 15. 15 above 15 is 20, then 25, and 30, and 35. No, it is going to come, and 15 will also not come. It has to be greater than 50. So 20, 25, 30 count are 3, and when the count is 3 and total possible outcomes are 20, 3 by 20 is the answer here. So this is one more part of the probability. We will be taking one more part to finish off this exercise. So till then, thank you so much. Take care of yourself.